Class, in this video we continue our discussion of section 4.4, laws of logarithms. In this video we'll be starting at the top of page 5 of your lecture handout. We are going to, in this video, combine logarithmic expressions. In the previous two videos we expanded a single logarithmic expression into a sum and difference of logs. When it comes to combining a logarithmic expression, we rewrite a sum and difference of logs as a single logarithm. So this first example here, right, we have the sum of two logs in the same base, and we're going to write that sum as a single logarithm. That's what we mean by combining. Now, when we apply the laws of logarithms in combining a sum and difference of logs into a single log, the bases of the logs have to be the same. This doesn't work if the bases of the logs are not the same. So we're going to combine log base 4 of 2 plus 2 times log base 4 of 5 into a single logarithm. Well, 2 times log base 4 of 5, right, by the power rule, we can bring that 2 inside the logarithm and make it an exponent on the number 5. Well, 5 squared is equal to 25, right? So by the power rule, right, 2 times log base 4 of 5 is equal to log base 4 of 25. And now we have the sum of two logs in the same base, base 4. And so by the product rule, this is equal to the log of base 4 of 2 times 25, and 2 times 25 is 50. So this sum up here of two logs is equal to a log base 4 of 50 as a single logarithm. In the next example, we have 1/2 times the log of base 2 of 6 minus 2 times log base 2 of 5. Again, we're going to write this difference as a single logarithm. And so this 1/2 out front of the log can be brought inside the logarithm and made an exponent on the number 6. And this 2, ignore the minus sign for now, this 2 can be brought inside the logarithm and made an exponent on the number 5. So we have, using the power rule, this is equal to log base 2 of 6 to the 1/2 power minus log base 2 of 5 squared, and 5 squared is 25. Now we have a difference of two logs, so we can apply the quotient rule, right? The log base 2 of 6 to the 1/2 minus log base 2 of 25. The 6 to the 1/2 is in the numerator, the 25 is in the denominator. Remember, 6 to the 1/2 is the same as square root of 6. So, applying the quotient rule, this is equal to log base 2 of square root of 6 over 25. Remember, 6 to the 1/2 is in the numerator, 25 is in the denominator. So we have log base 2 of square root of 6 over 25. So this difference of two logs up here is equal to this single logarithm down here. Alright, so that's with real numbers. Now let's do it with variables. So we have 7 times the log of 6 minus 4 times the log of x plus 1. And you recognize this is the common log, and the common log is base 10. So the 7 can be brought inside the log, made exponent on the variable x, and the 4 can be brought inside the logarithm and made an exponent on the binomial x plus 1. And so then we have the log of x to the 7th minus the log of x plus 1 to the 4th by the power rule. And now we have the difference of two logs in the same base. So we can combine these two logs by the quotient rule. X to the 7th goes in the numerator, x plus 1 to the 4th goes in the denominator. So by the quotient rule, this difference is equal to the common log of x to the 7th over x plus 1 to the 4th. In this last example, So this difference of two logs up here, right, is equal to the single logarithm down here. In this last example, we have 2 times the natural log of 2 plus 4 times the natural log of x minus 1/2 times the natural log of x plus 5. Remember, the natural log is a log in base e, right? That's special number in mathematics. So again, right, by the power rule, we can bring the 2 inside the logarithm and make an exponent on the number 2. In the second term, we can bring the 4 inside and make an exponent on x. And in the third term, ignore the minus sign. We can take the 1/2 and bring it inside and make an exponent on x plus 5. So when we do that, right, by the power rule, we have the natural log of 2 squared plus the natural log of x to the 4th minus the natural log of x plus 5 to the 1/2. Well, 2 squared is equal to 4, so this first term is now equal to the natural log of 4. Second and third terms remain the same. And now, right, we have a sum of 2 logs in the same base, so we can apply the product rule to that sum. That's equal to the natural log of 4 times x to the 4th. And remember, anything raised to the 1/2 power means square root. And so the natural log of x plus 5 to the 1/2 is the same as the natural log of square root of x plus 5. And lastly, we have a difference of 2 logs now in the same base. So using the quotient rule, right, 4x to the 4th goes in the numerator, square root of x plus 5 goes in the denominator. So the natural log of 4x to the 4th minus the natural log of square root of x plus 5 is equal to the natural log of 4x to the 4th over the square root of x plus 5. So this sum and difference of logs up here, right, is equal to this equivalent to this single logarithm down here. Okay. Now I want to point something out, that this sequence in combining this sum and difference of logs into a single logarithm, we did power rule first, product rule second, quotient rule third. That tends to be the best pattern that works in combining logarithmic expressions. Do the power rule first, do the product rule next, and do the quotient rule last.